This video is about the polar form of CR equations. Now CR equations are Cauchy Riemann equations. Sometimes in books it is written like this. So why we are interested in polar form is because of this. We know Z is equal to X plus I, Y. And in the graphical representation, I showed you this, that X is equal to R cos theta and Y is equal to R sine theta, right? So let's write Z in this form, which is R cos theta plus iota R sine theta. So now R is common, so R cos theta plus iota sine theta. Z is equal to R e raised to iota theta. Cos theta plus iota sine theta is e raised to iota theta. This is the Euler's formula. So complex variable can also be in this form, which is of the form r theta. This is the polar form. So that's why we need Cauchy Riemann equations in polar form to solve questions like this, to find the analyticity of this type of questions. So let's find the polar form of CR equation. Now let's derive the polar form of CR equations. So we know that a complex variable is of a form this. And also if the variable is r e raised to iota theta, then it can take this form also. Now let's equate these two things. So we equate these two things and give this equation 1, which is u plus iv is equal to function of r e raised to the power iota theta. Now differentiate this with respect to r, because we need to find r and theta form. So del u by del r plus iota is constant, del v upon del r is equal to, now differentiation of this function, which is f dash r e raised to iota theta, and now we will apply the chain rule, differentiation of this thing inside, del by del r r e raised to power iota theta. Now differentiation of this thing is, this is constant, theta is a variable, but we are differentiating with respect to r, so it will be a constant, and del r by del r is 1, so it will be f dash r e raised to iota theta e raised to iota theta. So let's give this equation number 2. Now we will differentiate this one with respect to theta. So differentiating with respect to theta, which is del u by del theta plus iota del v by del theta is equal to f dash, which is the differentiation of that function with respect to r. Now apply chain rule, differentiation of this thing with respect to theta. So now we get this, and differentiation of e raised to iota theta is e raised to iota theta, and also now we will apply chain rule to iota theta. Then differentiation of iota theta is iota, because del theta by del theta is also 1. If there is a constant iota, then it will be iota. So this is also simple differentiation. Now we got these two equations, equation number 2 and 3. Now we will compare these two equations. So comparing these two equations, what we get? See here, f dash r e raised to iota theta, e raised to iota theta, this thing is equal to del u by del r plus iota del v by del r. And in here we are getting this thing, this. So simply del u by del theta plus iota del v by del theta is equal to ri, that above thing, this one, because this is equal to this. So we got this, del u by del theta is equal to iota del v by del theta is equal to ri del u by del r plus iota del v by del r. Now just solving this, taking this inside, multiply, and iota square is -1, so we get this. Now comparing the imaginary part, we get del v by del theta is equal to r del u upon del r. So now these are the Cauchy Riemann equations in polar form. Also in here, if we arrange these in standard form, this is del u by del r is equal to 1 upon r del v by del theta, and del v upon del r is equal to -1 upon r del u by del theta. So this is polar form of CR equations. Thanks for watching this video, and always remember that math is everything.